classroom when we're done. But essentially what I want us to do is to talk about how we go from the equation of a line to a graph of a line. Um, so, and that's I guess if I'm going to do a title, equation to graph, and it is the sixth. So here's what I want you guys to do. We've done this, but it's a little weird. So I just want to make sure that we kind of remember. So you start off with an equation, and it's almost always going to be y equals, mostly because when we do stuff with graphs, we're always plugging stuff into x, doing some work, and then we get out our y's, and then we graph our points. And so what I'm about to give you is like the shortcut to all the crap that we did yesterday. Because the stuff we did yesterday was we plugged a bunch of points in, we graphed them, we figured out where they were going to be at, we were good. That's not really what we're going to be doing today. What we're doing today is trying to use what we know to shortcut the process a little bit. And so the way we do that is there's always going to be something with an x, okay? And so the way that we do this is it's going to be y is equal to the number that is going to be in front of our x is our slope. And then the number that we're going to have here afterwards is your zero term. And I don't know if you guys remember this from last semester. We did it like the last week before school was out. And man, I don't know about you, but that feels like 7 years ago. So that's why I wanted to make sure we could kind of see this. But generally, what you get with an equation of a line is you get a place to start and you get your direction with the slope. And so our zero term is always going to be, that's our y-intercept. That's the place where the graph is going to cross the y-axis. And it's the zero term because x is always 0 there. So this is always going to be 0 and then some number. Now, we've talked a bunch about slope, so I don't think it's going to be that big of a deal. But the way this is going to look is you'll have something that's going to be like y is equal to, I'm just going to make something up right now, okay? Let's say 2/3 x plus 1. The information you get from this equation is always in two parts. The thing that you want to do first is to say, what is my start value and where do I put it? So that's always this number that's off on its own that doesn't have an x attached to it. It's always got a plus or a minus over here. So this is your start. It means that the point that we're going to have, so graph the point 0, 1, because it's your zero term. The x is 0. This is your y value. And this is just going to be on that y-axis right there. That's where we start, okay? When you're done with that, what you're then going to do is take your slope and you are going to break that down. So this is now your slope. We know that 2/3, this is our change in y is the 2, because that's always on the top. Our change in x is the 3, that's always on the bottom. So that I know based upon this, that 2, since it's positive, tells me I'm going to be going up 2. And that change in x is the 3 means I'm going to be going over to the right 3. So I start at this point, and then to find the points that happen after that, I go up 2/3, make a point. Up 2/3, make a point, and I keep doing that. Now, that's the way we go about doing these things. And so here's the problem that we run into, that like this is my issue with remote learning. Right now, what I would normally do with you guys is this. I'd be like, all right, I taught this. Everybody, here's a bunch of graph paper. What we're going to do right now, we're going to do one of these together. And then we do it together, and I'd look and I'd walk around and I'd say, okay, yep, you got it. Yep, you got it. Nope, you got to change your one. Oh, you did your slope backwards. Let's do this differently. We get it all figured out, and then we come back and do it again. Here's the problem, guys. Like right now, you're going to have to watch me do this. And then we're going to have to go and look at Delta Math and see if we can do it on there. And then we're going to have to see if there's a lot of different things that are going to be transferring. And so it's hard to do this along with me and know if you've got it. So the reason why I'm recording this right now is so that, like, if you leave here and you go, oh man, what the hell did Bechtel say? I don't even remember what I'm supposed to do. That is why we're recording it. So you can go back and go, oh, wait, this is when he talked about that graphing thing. Hold on, fast forward. There's a graph. That's what I got to do. Dude, that's why we record these. So that if you forget, you can go back and go, there it is. That's what I got to do right there. And then you can do it. I'm also going to do this and show you Delta Math. I'm also going to do this and maybe show you that quiz thing. I just want you guys to kind of have a process, okay? So, for instance, I'm about to take a graph paper and do this one on there to show you what we have to do. You've seen what's happening. Now we're going to see it on the graph, and then we're going to do that a couple more times, and we'll see where we stand. I need you to do something for me, though, okay? If I get through an example, and there's a part of it that you're like, what in the hell did you just do? Please ask a specific question. Like, why did you start the graph there? Why did you go up this many and over this many? Where did you get this number from? Ask a specific question, because then it's really easy for me to clear that up. And I don't get it is a little harder because there's so many things I could go with. So if you could ask me specific questions, it'll make things a lot easier. So we're about to graph this. Let's see what we can do. So that equation was y equals 2/3 x plus 1. Again, when we did this, we said that was our start. That is the 0, 1. So I'm going to go down here, get to that 0, 1, put a point here. So every time you're going to start with these points, whatever that number is off on the side, that is where you start your graph, and it's always on the y-axis, okay? So from here, we're either going to be going up with the slope or we're going to be going down with the slope, depending on what it's going to be. Now, the next thing that we did is took our slope. This number here is the change in y. This number here is the change in x. So that 2 is going to be up 2. 3 is going to be over 3. So when we graph those next points, we start from our original point here, this y-intercept, and I go with these processes. The up 2, 1, 2, over 3, 1, 2, 3. That is my next point. And then I'm going to do it again. Up 2, 1, 2, over 3, 1, 2, 3. That's my next point. And I keep doing that until I run out of graph. Up 2, over 3. I have run out of graph this way, which means I have a line that goes off in this direction. Now, I can just kind of get the general idea this way, or if you want to keep doing the same steps, where you're going over 3 and now you're going down the steps, totally fine. You can keep doing that until you run out of graph on both sides. Totally fine. You don't have to, though, okay? The question got asked, do we always have to keep going? As long as you have 3 points, you have a place to start and 2 to give me a direction, that's all I'm going to need. And then you could just do an arrow on this side and we're going to be done. That's what we got. Now, guys, that's all we have to do with these. And I like showing you all of the points so you can see it continues in this direction. I only need 3, okay? And actually, the great thing about the Delta Math, you really only need 2, and then it draws the line for you, which I really dug. Like, I looked at that when we were kind of coming up with the equations. I'm like, that's all I got to do? All right, here we go. Okay, so I'm going to give you another one, show you what we have to do. I'm going to give you a couple different examples of, like, if you have this type of slope, this is what you do. If you have this type of slope, this is what you do. And then what we'll do is we'll go to Delta Math and see what that looks like, okay? So I'm going to write one here. Let's go new equation. Y equals negative 3/4 x plus 5. There we go. All right. 2 things. First thing we got to do is our start. Okay. If somebody already did the Delta Math, because if somebody said that, you rock. I appreciate that. Make sure you get 100% on that. And then when we get to there, you know, you could turn off your brain for a minute, or you could listen to all of the lovely jokes that I try to make and fail at. Either way is fine. All right, plus 5. That's where we're going to start. 0, 5. So here, 1, 2, 3, 4, 5. Boom, there's our starting place. Now, this slope, I made it a little different. I did a negative. And I put that negative out in front because most of the time that's the way they're going to do it. So what I want to make sure that you can see is that when we do this, I'm going to do this above so you guys can see that. When I write it above here, I'm going to bring the negative up to the top. I always, when there's a negative, it's either got to go to the top or the bottom. It's so much easier when you put it on the top. So I rewrite it with a -3 up and a +4 down. And the reason why I do that is just because it tells us direction, and I don't have to worry about, do I do it up? Do I do it? No, just do it this way. This top one is our change in y. This bottom one is our change in x. So if I have a negative change in y, that means instead of going up 3, this tells me I'm going to be going down 3. That change in x being a positive 4, we're still going to the right 4. So that helps me get to my next points, okay? Starting at the original point that we did here, we're going to be going down 3, right 4. Okay, so from here, 1, 2, 3, 1, 2, 3, 4. There's my point. Then from that one, 1, 2, 3 down, 1, 2, 3, 4 over. Now you notice I'm not going to have any more space here. So people ask, do we have to keep going? No, man, I can totally just draw a line here. This is fine. I do want to make sure that you put an arrow on both sides because that lets me know that we keep going in both directions. If I had more graph, I could go this way. If I wanted to graph this way, I could. But that's the reason why we put arrows on both sides, okay? So that gets us what we do when we have a negative slope as we do this. And this could be a negative number. We could be starting down on the bottom here. This just tells us we're going downhill as we're doing this. Okay, so we've done 2. I'm about to do one other thing, and I want to make sure we see it. But does anybody have any questions that are happening with this before I move on? Like, where did this come from? How do I do this? What are we going to do? I got a no question. That's awesome. Got 2 no questions. These make me happy. Okay. So what I want to show you, one of the things that exists to mess with you a little bit is when they give you a whole number slope. And we talked about this before, but I want to show it to you because that is a little confusing, especially when we're already trying to figure this out with an equation. So let's start off. We'll go y equals 2x minus 5. Yeah, 5 is good. Okay. When we look at that, again, your process is the same. Always start with your start value. So let's do that first. This is our start value. Now it's a negative this time, which means that our first point is going to be our y-intercept at 0, comma, negative 5. So I'll go here. 1, 2, 3, 4, 5. We're just starting down here. Again, it's not any different. It's just that we do this in a different place. The number in front of the x is always your slope. Whether it's a whole number or a fraction, that is your slope. So if this is my slope, the first thing that I have to know is that I have to write it as a fraction because the top is my change in y, the bottom is my change in x. So I have to have a fraction to have both parts of moving. Otherwise, you'd just be going up or you'd just be going down, and that's not enough. So if I have a whole number, remember, a whole number can be written as a fraction. You just have that number over 1 because dividing something by 1 keeps it the same number. So if I'm going to write this, the 2 is on the top and I'm going to put a 1 on the bottom. Anytime you have a whole number, that's how you do it, okay? So with this, that 2 is a change in y. It's positive, so I'm going to be going up 2. That 1 is my change in x. It's a positive. I'm going to be going right 1. So from this point, and man, we're going to have a lot of points to do for this one because these are small numbers. Totally fine. Up 2 over 1, up 2 over 1, up 2 over 1. Now, I do want to tell you, somebody asked, do we always have to keep going? I got 4 points. I could draw this. And if you decide to do that, you totally can. For me, I like using this to have more because my drawing skills sometimes lack when I go in this direction. So I want to make sure that I don't screw something up and I know where I'm at. So for this, draw a line through it. That is my direction there. That is my direction here. We're in good shape. Okay. I have taken care of positive y-intercepts, negative y-intercepts like this one, positive slopes and negative slopes, and whole number slopes. I think we've got everything. Does anybody have any individual questions? How do you know which direction you're supposed to go? That's a great question, actually. What you want to think about is this. The start value is always the place you start. So that part is basically it anchors your line. That's where we start. To know which direction you're supposed to go, once you have written your slope as whatever fraction it's going to be, that top number of the fraction, no matter what, is your change in y. Now, what we remember is y-axis is always vertical, so that's always up and down. So basically, you look and see if it's a positive number or a negative number. It's a positive number, you go up. It's a negative number, you go down. And whatever that number is tells you how many places you go. So that's why for these, we went up 2 every time because that top number was a positive 2. The bottom number is your change in x every time. So that's always horizontal movement. If it's positive, you go to the right. If it's negative, you go to the left. That's what we're looking at, okay? I hope that that helps. And if it doesn't, that's fine. That's what we want to kind of think of. And I could do some more examples. I'm going to show this to you on Delta Math because we are in a little bit of a time crunch. We got about 11 minutes. We're fine, but I want to make sure we're able to do this. So right now, I guess my question should be, do you want me to do Delta Math yet, or do you want me to do another one on here? Because I'm happy to do another example. I think that would probably be good. But do you guys tell me Delta Math or paper? Write your opinion, and I will go with which way you guys say, because I think we can learn from both. Delta? Okay, perfect. We can totally do that. This, well, be patient with me. I'm going to change the sharing, and I think I can do that quick, but I don't know. So give me a sec. And if I can't, well, I mean, I'll probably swear, and then we'll go from there. Okay, perfect. It worked. All right, so I'm going to go to Delta Math. Oh, no, that's Desmos. That's not Delta Math. And some of you guys are in there already. Good for you. Okay, back. Let's go to Tools. And let's go to View Assignments first. And let's go to Tools and Copy Assignments. And I'm going to go to, oh, not this person. I'm going to go to me. And we're just going to look at this. Okay, so here's what our assignment is. Graphing lines from equations, finding the slope graphically. Okay, this is what we've been doing. Now, y equals 1/2 x plus 5. You guys ready? That plus 5 that I have right there is my starting value. So it's 0, 5. I'm going to go on here to the 0, 5, and I'm going to put my dot, boom, right there. Now, this is why I love this, because right now, it gives me the second place for whatever I'm going to do, okay? So, I'm just going to set it off here. This is clearly not it. If we look up here, this slope is 1/2. My change in y is 1. My change in x is 2. So that means I go up 1, and here this 2, I go to the right 2. So from here, I'm going to go up 1 to the right 2. And then from there, it would be up 1 to the right 2. So these are, if you look at C, you see how those are still on the same one. And I could keep doing those steps and show that they're always going to be in the same place. Or if I just want to go down here and go up 1 to the right 2 and make my point there, boom, it's right there. And I can even follow from here, 1/2, up 1/2. This is the line that follows this equation, okay? We go down, submit the answer. It's not even asking me to do anything. You want to have this graph be right? Yup. And hey, look, it tells me what I'm doing. It's got the rise and the run, up 1, right 2, shows us we did it this way. And guess what? Y'all, I did great. Does that make sense? All right, cool. Let me do this again. New problem. Hey, look, it's -1/2 and 3. All right. Always get your start value, the 3. 1, 2, 3. Boom. Now, we got a negative slope. So the negative goes with the top. And I don't normally do this, but let me type this on here to see if we can actually make this work. Annotate. This will be interesting. Text. So we're going to put a -1 and then a 2, right? So this top one here, this is your change in y. This bottom one here, this is your change in x. So what that means is that change in y means I go down 1, change in x means I go over 2. Okay, so that's what we're going to be doing based upon that 1/2. I'm going to get rid of that and say then from here I go down 1. Oops, hold on. I go down 1 and I go right 2. Click. Then I'm going to check and see if that still works. Down 1, right 2, down 1, right 2. All right, that works for all of these. Submit my answer. You sure you want to? Yes. Yep. Good job. All right. And by good job, I basically mean, y'all, I think you got this. So I am going to clear my drawings and ask, do you guys have any questions that go along with what we're doing here? I can do a new problem. We can do a bunch of these. That's fine. This has got x minus 3. Do you guys want me to do one like this? Because this looks a little weird. All right, here we go. X minus 3. Again, I'm not going to do anything until I deal with that 3. That number there is my start value. No matter what. Forget about the x. Don't worry about this being weird. We always start at that number. So 0, -3 means I start at -3. Boom, right there. Now, this is a little confusing. I am going to do annotation for this one, and I'm going to type this in for just a second. Right now, what we are looking at is y equals x minus 3. I'll move this here. What you could be thinking about that as is y equals 1x minus 3. We don't normally put the number 1 in front of our variables if we just have one of them. But that's the number we're going to represent as our slope, is just a 1, okay? Now, again, we said if we have a whole number, that means that my slope is equal to 1, or if I want my change in y and my change in x, I could do that as a fraction of 1 over 1, where I'm going to be going up 1 and over 1 for each of these, okay? And that's what you do if you have a number here. There's like an imaginary 1 right up here in front, okay? And that's what we're going to be looking at. So if my slope is 1, I'm going to be doing 1 over 1. That means that my change in y is equal to 1. My change in x is equal to 1. So up 1, right 1, up 1, right 1 as we do all of this, okay? Now, let's see if I can do this without screwing too many things up. Okay, so I got this. Turn this off so I'm not annotating anymore. Back to this. So I go from here, up 1 to the right 1, and let's keep looking. Up 1 to the right 1, up 1 to the right 1, up. Yeah, it works for all of them. Okay, submit the answer. You sure you want to do this? Heck yes, I do. And that's how we do this. It did work and it's fine. Okay, I am going to go back and clear out my drawings. And somebody asked, are we always going to do that every time with equations that are similar to this? Yes. Anytime that you have something that is going to have nothing in front of the x, the slope is always 1 over 1. Or sometimes they'll give you a 2 or a 3 or a 5, and it's going to be that number over 1, no matter what it is that we're going to do. Let's see if they'll give us one like that, actually. So here, -2, that's perfect. When we look at this one, if I graph this one, I think it's going to be similar where we don't have a fraction. Start with that 6. So 6 right there. Now that -2, if I do -2 over 1, which is what we do with the whole number, my change in y is -2, so down 2. The over 1 is always to the right 1. That'll be our graph. Down 2, over 1, down 2, over 1. We're good to go. Submit the answer. Yep, that's what we're looking at. Okay. Now, guys, I've talked a ton about this stuff. And so here's what I'm going to do. Right now, I'm going to stop sharing and I'm going to stop recording.